Hey everybody, just wanted to make a quick little video to show you proportional relationships and what they look like. So when you have a table and someone asks you, is it proportional? Basically they're asking you, is the ratio of y over x always the same? In other words, if you take the y values and you divide them by their corresponding x values, do you always get the same constant of proportionality, same multiplier? Remember, a proportional relationship, something times x always equals the y, right? So in this case, the first table, you can see when x is 12, y is 3. When x is 20, y is 5. When x is 16, y is 4. When x is 8, y is 2. So the question is this a proportional table? And in order to be proportional, the ratio of y over x is always the same. So basically you're asking yourself, is 3/12 the same as 5/20, the same as 4/16, the same as 2/8, right? And what we can see there is, yeah, it's always the same. If you simplify 3/12, divide top and bottom by 3, you're going to get 1/4. If you simplify 5/20, you're going to get 1/4. If you simplify 4/16, you're going to get 1/4. If you simplify 2/8, you're going to get 1/4. So in all of the situations here, the ratio is always 1/4. So this is a proportional relationship. When you graph a proportional relationship, it looks like a straight line that goes through the origin. You guys can see that these four dots all line up, and if you extended it, they go through the origin. The rule for this table is y equals 1/4 of x, because the ratio of y over x in simplest form is 1/4. We call that the constant of proportionality. It's the multiplier. It's what you're going to multiply the x by to get the y. 12 times 1/4 is 3. 20 times 1/4 is 5. 16 times 1/4 is 4. And 8 times 1/4 is 2, right? If there's some constant you can multiply the input by, the x value by, to always get the output, the y value, then you have a proportional relationship. And if you graph it, it will look like a straight line that goes through the origin. That's what every proportional relationship looks like. So as long as you can prove the ratios are the same throughout the table, then you've proved that it is, yes, proportional. If it's something where the ratios are not the same throughout the table, even if there's one exception, then it's no longer proportional. Watch. If I were to take this one here, and instead of this being x value of 16 and y value of 4, I change to a y value of 7, right? Look, these three dots line up, right? But this one's not on the same line, right? So this is no longer a proportional relationship. In order for it to be proportional, all of the dots have to line up, right? All the ratios have to be the same, and it has to go through the origin when you extend it. So in other words, when x is 0, y is 0. Because a proportional relationship is always modeled by the equation y equals kx, where if x is 0, y is also 0. So it has to go through the origin. Let me show you another example. So that's one. Let's close that one. Here, this is another proportional table, right? The ratio of y over x is always the same. 9 over 3 is 3. 15 over 5 is 3. 21 over 7 is 3. 27 over 9 is 3. So the ratio always stayed the same. It was always what? 3. So this is an example of a proportional relationship because the ratio of y over x is always 3 over 1. And you can see when we extend this one out and we look at it, all these dots line up and they go through the origin. Watch, if I were to insert an equation for this one, it will be y equals 3x. You can see that line goes through all the dots and through the origin, right? So all of these are on the line y equals 3x. This is a proportional relationship. So if you were asked, is this table proportional? You say yes, because all the ratios of y over x stayed the same. If you make it not proportional, all it means is that one of these ratios is no longer the same. If I change that 5 to a 6, now all of a sudden it's not proportional. Now you might be thinking, well, it looks proportional, right? But if you zoom in close enough, you'll see that one of these dots is not on the line, right? So was it 26, right? Very, very close, but it's not going to be on the line. So when x is 20, y is 6, right? Let's see. So when x is, oh, my bad. I didn't change the right one. I changed that one up there. Silly me. This is the one I wanted to change. So these dots are still proportional. But if I change, let's say, one of these values to, I don't know, instead of 3.9, it's 3.7, right? Now you can see it's no longer proportional because they're not, all the dots are not lined up, right? This one's off the line. So remember, it all has to be lined up and go through the origin, which means basically the rule has to work for everything, right? So if it's y equals 3x, right, that means that x times 3 is y, 3 times 3 is 9, 5 times 3 is 15, 7 times 3 is 21, 9 times 3 is 27, and then all the dots line up and it goes through the origin. So the ratios stay the same throughout the table. If the ratio is the same throughout the table, it's proportional. If the ratio is not the same throughout the table, it's not proportional. Take a look at the next one. This one is a situation that is also proportional. You can see here 1 times 5 is 5, 2 times 5 is 10, 3 times 5 is 15, 4 times 5 is 20. So when you multiply the x by 5, you get the y. Hence, the equation for this one will be y equals 5x, because the ratio of y over x is always 5. 5 over 1, 5. 10 over 2, 5. 15 over 3, 5. And 20 over 4, 5. If you made it any situation in this table where that ratio was not constant at 5, then no longer proportional. So right now, they're all dots that line up. Let me turn off the blue line and change that to 5. Okay, see? Y equals 5x, right? They're all dots that line up and they go through the origin. That's what these green dots are, because it's proportional. But if you change one of the values so that it's no longer the same ratio throughout the table, let's say you make that 8, now all of a sudden what you'll notice is that all the other dots are lined up, but that one's not on the line. So this is no longer proportional, right? Remember, to be proportional has to be a ratio that's always the same throughout the entire table, right? So the ratio of y over x stays the same, period. That's the definition of proportional relationship. Output to input, always the same. So in this case, you'll notice that 5 over 1 is 5, but 8 over 2 is not 5. 8 over 2 is 4. Hence, this would now no longer be proportional. That's what we can see here. That dot is no longer on the line, right? So if we make that 10, now it's proportional, right? Because now the ratio of y over x is always the same. So when you're asked, is the table proportional? All you have to do, y over x throughout the entire table, and see if that ratio of y over x is the same. If it is effectively the same value, then you have a constant, which is what you multiply the x by to get the y, and you have your equation y equals that constant times x. And you're good to go. All right? Hopefully that helps.